Hello everyone, my name is Timothy Lee Grant. Today we are going to attempt to do this problem, number 543, diameter of a binary tree. Supposedly it isn't easy, okay? And I know that I've done this problem before. Now, that doesn't mean that I am going to be able to do it now. I can't remember how long ago I did it. I think it was a little while ago. But it will give me an opportunity to try a problem that I have done previously in the past, but this is long before I started my new method of really trying to understand problems. And in the past, I would just go and do a problem, not really understand it, and then move on to another problem, and I wasn't learning that much. Now I have a new method, and I'm going to look at this problem, see if I can get it. If I can, I'm going to analyze what that means. If I cannot, then I need to analyze why. What concepts am I missing? What's going on? And try to evaluate that way. All right, so given the root of a binary tree, return the length of the diameter of the tree. Okay, so we're given a root, and I want to find the diameter. So what is the diameter? Like, what does that mean? The diameter of a binary tree is the length, okay, of the longest path between any two nodes in a tree. The path may or may not pass through the root. Okay, so I think what this means is like, this is a path, this is a path, right? And like this is a path. Technically that's a path, right? Like I think that's what it means. Okay, so the length of a path is any two nodes. Okay, so for this one, I want to find the diameter, so the maximum. So that's going to be 1, 2, 3, 4. Or, I don't know if they're counting like nodes or edges. Okay, so that's actually kind of an interesting point right there. There is a difference between if you're counting the edges or if you're counting the nodes, right? So number of edges. So 1 edge, 2 edge, 3 edge. So 3 should be this one right here. Yep, there it is. Okay. Cool. So now obviously I am going to want to traverse this graph. Okay, so how do we traverse a graph? We have a base case. So what is the base case? So if not root, okay, if not root, return 0. Okay, and I think 0 because the output needs to be a integer. Okay, now what I'm going to do is I'm going to find length of left, okay, and that's going to be equal to the diameter of binary tree, okay. I don't quite know would it just be root dot left? I'm not sure about this. So what I'm thinking about doing is, I know that I need to traverse, right? So I'm going to go down this left, and I want to get like the number of edges. Or the height. So how do I capture that height as I'm coming up? So I'm at 0 right here. Once I get to this base case, I'm going to get 0 back, right? When I look at this left, I'm going to get 0 back. So I know that there's nothing below me. And then now I want to pop up. So when I pop up, I want to say that my height is 1. Okay, yeah, so I want to say that my height is 1 so far. Maybe I need like a traverse function. I don't know. Hold on. Let me try this. I come here, def traverse, and then self and root. Maybe I don't need, I'm not sure. I'm not sure. How do I get the height? How do I get the height of this? Okay. Max. I need to initialize max length, right? So, do I do it here, like a member variable? So like, do I need to do it in it? Oh my goodness, this is awful. Okay, this is really bad. Def. I'm glad that I'm doing this problem because it obviously represents that I have huge gaps in my knowledge on how to even traverse a tree. So I need to learn how to traverse a tree, how to determine my height, how to pass up that height, how to save values in. So self.max length is equal to 0. So max self.max length is going to be equal to max of self.max length and length or height of left. Okay, this is going to be height of left plus height of right. Okay. So I need to do the same thing, but on the right. Okay. Now, I myself need to say where I am, like my height. So this is the height at the base case. So I'm adding these. Changing this. Can I say like current height is equal to the maximum of and so I take this, it's the whichever one is the maximum, and then I add 1 to it because of myself, right? Now I can't do this doesn't work. Return current I can't do that. And the reason is because I need to return the longest path. So that's why I think maybe I do need to use a helper function. So let me come here, copy this, actually go like that, move it in there. Then I traverse. So then I do like self.traverse. I pass in the root, okay, and then I return this self.maxLength. Okay. Does this make sense? This is like, I'm taking the height of whichever height is, because at this point right here, it's going to be the height of all the longest path down here. Okay, so its height, the height of the left, and then plus the height of the right. Is this going to be 1 and this is going to be 1, right? So I come here, this is 0, this is 0, and then I pass up 0, the maximum of 0 and 0, plus 1. So this is 1. Then I come here, bing, bing, 1. And then I say that the maximum length is 2 because it's 1 and then 2. Oh, I don't want to press submit because I don't think it's... I'm not a huge fan of... Oh, maybe actually I don't need this in it. If I'm doing it like this, I can do this. And then I don't have this constructor. And now I feel a little bit better to press submit, but I'm okay. Diameter. Oh, right, because I need to do this self.traverse. Come on. Okay. Let's see. Come on, come on, come on. Okay, come on. Yes! 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 Okay. So this doesn't conclude my time with this problem because I still need to kind of mull over the problem a little bit, think about it. I'm gonna go see, are there any other like solutions? Is this the way that they did it as well? Let's just see. Okay, so they did a function within a function. Okay, that's fine, that's whatever. So left and right, traversed there. Non-local result. Okay, so that's how they did that. Okay, so this is like max length. And then they did result is the maximum of my current and the additions, and then return back up the height. Okay, so yeah, this is the way that you're supposed to do it. Okay, cool. There's that. What I think I need to do, so what does that mean for this problem? That means that I was able to kind of figure it out. I was able to reason through it. This is a problem that I've done a very long time ago, I believe. But I was able to think it through and actually get it. I feel like some stumbling blocks in my conception, even though I was able to get it, that it worked, I'm trying to analyze where I was a little bit unsure of, which is I need to contemplate the idea of how to keep track of my current state, in this case it's height, within recursive calls. Okay, that's something I need to think about, put in my head, like when I'm about to go to sleep, think about that a little bit. Okay, I also need to I'm just going through kind of the experience that I just had and trying to identify my stumbling blocks. Yeah, how to keep track of where my current state when I'm doing recursive. That's like one of the biggest ones that I think I was having the stumbling with. And then I guess just thinking about the maximum length is like this. Height of left, height of right added together, and not thinking about a +1. And now, so I got that correct, but I think this is because because I'm counting edges, not nodes. If I wanted to count how many nodes there were, see, that's another thing I need to think through. If I wanted to how would this problem have changed if I was talking about the number of nodes instead of edges? So this is the kind of questions that I'm going to be trying to think through about on this problem. So, awesome. I was able to solve it, which actually very much surprised me. Cool. Moving forward, I'm gonna keep contemplating these ideas, and yeah. So thank you for watching this video. If you want to join me on more Leetcoding, on the Leetcoding journey, subscribe to this channel. I would love to have you around. Hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I'll see you guys very soon.